Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about radicals. What is radical? We all know that this one here is called the radical sign or symbol. And the number inside the radical, for example, is to say 8x. That entire thing is called the radicand. And if there's no number right here, that's assumed to be a 2, and that's called the index. Sometimes it could be a third power, 3 or 4 index or fifth root, so it varies, okay? Again, that's called index, and then if there's no number here, that's assumed to be the index there is 2, okay? So before we simplify radicals, what are the perfect square? The perfect square are the like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, uh, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on and so forth. When you say cubes, these are the number that you multiply 3 times. So what's 1 times 1 is we know is 1. 2 times 2 times 2 is 8. 3 times 3 is going to be 27. Hold on, that's not 27. 27. 4 to the third power, or 4 times 4 times 4 is going to be 64. 5 times 5 times 5 is equal to 125, and so on and so forth. Perfect fourth means say you multiply the number to itself 4 times. So for example, 1 times 1 times 1 times 1 is going to be just 1 there. 2 times 2 times 2 times 2 times 2 is going to give you 16. 3 times 3 times 3 times 3 times 3 will give you 81. 4 times 4 times 4 times 4 for the fourth time is 206. And 5 times 5 times 5 times 5 will give you 625, and so on and so forth. The only thing I would like to add here is that you have to understand that it's not only 1, 8, 27. It's also -1, -8, -27. Okay? Or let's go with -1 here. Okay? With -1 here, because I can multiply -1 3 times, and the answer is still going to be -1. I can multiply -2 3 times, and the answer is still going to be -8. I can multiply -3 3 times, it will be going to be -27 still. So a perfect cube there can be considered as -1, -8, and -27. If you notice on a cube, which is an odd number, 3 times, you can accept a negative, because a negative times a negative times a negative on the third time is still going to be -1. If you multiply it again 2 more times to make it 5 times, which is an odd, it will still be -1. Unlike if it's an even square or fourth, it won't work. It has to be positive, because when you multiply 2 negatives or 4 negatives on the same, it will be a positive. Okay. So let's start now here simplifying radicals. There are so many ways and stories on how to simplify radicals. Okay. But I'll just show you this one way. Okay. If you have a way that works, and you get the same answer and mathematically correct, I'm totally fine with that one. Okay. Square root of 81, I like to do prime factorization. I break it down to 9 and 9. Remember, guys, that the index here is 2. If the index there is 2, I need to group them into 2 parts. Since here I have 2 9s already, that's one pair. So that means the answer is just going to be 9. Some, they would like to complete the prime factorization. So if you break down the 9, you're going to get here a 9 and 9. 9 can be 3 and 3, and 3 and 3. Those are prime numbers, and we have to group them by 2s because the index is 2. a group of 3 and a group of 3. So two threes will be out. So 3 times 3 is going to give you a 9. Okay, very simple. What if the question is cube root of 81? Now the index here is 3. That means there should be 3 items in a group. So if I break it 9 and 9, it won't work anymore because there should be 3 items. So I'm going to break down the 9 to 3, 3, 3, and 3. Again, in a group, there should be 3 items. So there are 3, 1, 2, 3. That means 1, 3 will go outside because of that. And this 3 here that has no group will remain inside of the radical sign, which is just 3 there. So again, one more time, this 3 here by itself, that's how you get that one. And this group of 3 here made one of the 3. And you just drop the index here. That's why we kept it over there. Okay. Now, what if there's a coefficient outside and the index is 4, there's still 81. So again, 9 and 9, 3 and 3, 3 and 3. I need to group them into 4, so all of them will work. So a 3 will step out, but the coefficient of 2, you multiply it by 2 there. 2 times 3 is going to be 6, and that's the answer. Kaboom. Now, just a reminder that if you have a negative 1 times negative 1, it's going to be positive 1. Remember, there are 2 of that one, so it is an even. An odd, because negative 1 times negative 1 times negative 1, it will still be negative 1 there. Negative 1 times negative 1 times negative 1 times negative 1, which is an even, it will produce a positive there. Negative, 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 negative. 5 of that is going to be an odd. So the answer is still going to be negative 1. Why am I explaining that to you? Because if you have, this should be a 3. Okay. If you have a cube root of negative 1, that means you can come up with negative 1 times negative 1 times negative 1. You have to group them into 3 parts, and I have a group of that. So the answer here is just negative 1. If I have cube root of negative 8, then I can have negative 2 times negative 2 times negative 2. That will give me 3 groups of that. So the answer is negative 2. Okay, easy, right? Another way of doing this is this one here. Cube root of negative 8 can be made at negative 1 times 8. We can make negative 1 as negative 1 times negative 1 times negative 1, and 8 is 2 times 2 times 2. That means we have to group them into 3. So one group of negative 1, so it's going to be negative 1. One group of 2 times 2, the answer is still going to be negative 2. So whichever is easier for you to understand, I'm totally fine with that. Now, this time here is a fifth root of negative 32. So I know that negative 1 times 32 is the same thing as negative 32. But negative 1 can be broken down to negative 1 times negative 1 times negative 1 times negative 1 times negative 1. 5 of the negative 1. And 32 can be broken down 2 times 2 times 2 times 2 times 2. Oh, by the way, how did they get that one? Okay, because 32, I'll put it here, 32 is 16 and 2, 16 is 8 and 2, 8 is 4 and 2, 4 is 2 and 2. If you notice, I have 1, 2, 3, 4, 5, 5 twos, okay, for 32. So 1, 2, 3, 4, 5. And the index is 5, so I have to group them into 5. Negative 1, and times 2. So the answer here is just negative 2. Very simple, right? All right, let's move on here now. So simplifying radicals, okay? When we have a square root of 500, we break this down into 5 and 100. You can use 50 and 10. You can use 250 and 2. You should still get the same answer when you do prime factorization. 5 and 20, and this one will be 10 and 2, and this will be 5 and 2. Okay, so the index here is 2 because it's invisible. So one group of 5, so it will step out. One group of pair of 2 there will step out. And then this 5 here has no partner or has no group, so it remains inside. 5 times 2 is 10, so the answer is 10 square root of 5. Again, you can have a different work, but the final answer should be the same thing here. Next, cube root of negative 54. Again, I like to put there a negative 1 times 54. That easily tells me that there should be a negative 1 outside because negative 1 times negative 1 times negative 1 will give me a negative 1. So I'll put the negative 1 there now. cube root of 54. Now you can break down the 54. I'm going to get 27 and 2. 27 is 9 and 3. 9 is 3 and 3. And again, the index here is 3. So that means there should be 3 in a group. So that brings out the 3 outside. So times 3. The 2 has no partner, so it remains inside. So negative 1 times 3 is negative 3. Cube root of 2. And that's the answer. Next, there's a coefficient of negative 3 there, fourth root of 625. We know that 625 is 20 as 25 times 25. Break down to 5 and 5, 5 and 5. And the group should be 4 in a group because the index is 4. So because of its fourth root, so the answer will be 5. But there's a negative 3 waiting outside, so the answer is negative 15. Kaboom. What about if we include variables? Okay, how does it change the problem? How does it add more? It's not really. It's the same idea. It's just a little extra. Okay. Again, the index here is 2, so I'll break down the fourth eight to 2 and 24. 24 is 2 and 12. 12 is 2 and 6, and 2 and 3. So that means I'll have one, two groups of 2 will go outside. So I'm gonna write here 4. Okay, and then a 3 will remain inside, so I'm going to have a square root of 3 there. Clear? Now I have a S5. That means I have 1, 2, 3, 4, 5. 5 S's there. So I have to pair them, one pair, another pair. So I'm going to have S squared there because there are 2 S's. But this S here will remain inside because there's no partner, and that's the answer. Kaboom. Easy, right? Now let's break down the negative 108. Again, I have a negative there. So I know already that's is equal to negative 1 times 108. That negative 1 can make 3 negative 1. So I know I'm just going to bring out a negative 1 outside. Okay. So then I'm going to break the 108. If you break down the 108, 2 and 54. 54 is 2 and 27. 27 is 3 and 9. This is 3 and 3. Now, this is a good problem. That means I'm going to have a negative 1 outside and a 3 outside, cube root of, I have a 2 twos. They cannot make a form of 3 twos in a group, so that will remain inside. 2 times 2 will be 4, okay? Because 2 and this 2 has no enough quantity of 3 in a group. That's why we have end up with a 4 there. And then F, 1, 2, 3, 4, 5, 6. One group. So F squared. G5, 1, 2, 3, 4, 5. One group of G. So one group of G goes outside and two G's inside. Okay. And H2, there's no way you can make a 3 there. So leave the H2 inside. And then negative 1 times 3 will just give us negative 3 there. So I will just write here negative 3. And that's the answer for the second problem. Next, what if we have a 2 index? What if we have 2 as a coefficient outside? It's the same thing, okay? The index is 4, remember that? So let's break down the 96. 96 is 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3 there. Again, there should be 4 items in a group. So 1, 2, 3, 4. That will give us, let me erase this portion here so I can write my answer. So my answer here will have a 2 outside because of this 2 here times 2 outside because of that. And then this 2 and 3 will be multiplied and they will just remain inside. And then how many m's do we have? 1, 2, 3, 4. So remember the index is 4, so that's already one group. So I'll put an m there. And 3 is not enough to make a 4 items in a group. P13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3. That's going to be P to the third power. And this P here will remain inside. What's 2 times 2 there? That will give us 4. So I'm going to erase that portion there and write it 4. And that's the answer. Kaboom. Very simple, right? And I hope that you learn how to simplify radicals now. As always, kaboom.